This works for any polynomial. It could be a polynomial that looks just like x plus 1. It could be your 5x to the third plus x plus 7. Or even one more example, if it was h of x was negative 1/5 x to the 10th plus x to the 9th minus x to the 8th, all the way down some terms in before to 3. What matters with all of this is what is the coefficient of the leading term, meaning what is the number in front of the x with the highest degree, and what is the last term. Now, if this last term didn't exist, it would be 0. And we would have to factor an x out of every single term. Okay, so I want to go ahead and start with the possible rational zeros of this. And the key word with all of this is this word possible. So what we do is we look at the coefficient in front of the largest degree, which is x to the 4th, and the constant term. So what we are looking for is a list of the factors of the constant term. The constant term is the whole number at the end. In this case, that constant term that we're going to be referring to is 6. Divided by the list of the factors of the leading coefficient, which in this case is 1, because that is the coefficient of the largest term. So what does a 0 mean? What we're trying to do is we are trying to make a list of possible zeros. And what that 0 means is that where could it be possible that this graph touches the x-axis? Now, because the degree of this polynomial is 4, and the degree of this polynomial is 4 based upon the fact that the highest power is 4, this graph could touch the x-axis at most 4 places. So we are making a list of all of the possible places that can happen at. After we find that list, what we have to do is test using synthetic division what values are zeros. So again, the first thing we need to do is we need to make our possible list. Then after we do that, we can test that list. All right, so let's go ahead and make that list. So the constant term is 6. The possible factors for 6 would just be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. And the possible factors for the leading coefficient, this isn't bad because this leading coefficient is again 1. So that's just going to be plus or minus 1. So what are the numbers that we have to go through and test using synthetic division? We have to test all of them. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And we will get at most 4 of those values that work. And the values that work again, that means we're trying to find out where does this graph touch the x-axis. All right, so this one's a little bit different from the last one, but we're going to do the same thing. We want to find all of the possible rational zeros. And we get that by making all of the factors of 9. And I use 9 because it is my constant term. And then I go through and divide that by all of the factors of 4. So we're actually going to get quite a few number of values here. So the factors of 9 are 1, 3, and 9. And the factors of 4 are just 1, 2, and 4. And it doesn't look like there's that many possibilities, but we certainly have a lot. So let me go through this step by step. What we're going to do is start off with going and taking, this is going to be 1 divided by 1, which gives us 1. Next up, I have 1 divided by 2, which gives us 1/2. The next one, I have 1 divided by 4, which gives us plus or minus my 1/4. All right, so I did all of the fractions that could have a numerator of 1. Now I'm going to go to the next piece and use 3 as the numerator for all of them. So now I have 3 over 1, which is plus or minus 3. The next one would be 3 over 2, which gives me plus or minus 3/2. And the last one that'll have a numerator of 3 is going to be 3 over 4, which is plus or minus 3/4. But we're not done yet. Now we have to go through and do exactly the same thing, only now we're going to look at a numerator of all of them that have a 9. So now we're going to have 9 over 1. That'll give us plus or minus 9. The next one would be 9 over 2, which gives us plus or minus 9 over 2. And the last one we will have would be plus or minus 9 over 4. Now the challenge is going to be to put all of these in numerical orders, going from smallest to largest. So let's go ahead and start with the smallest fraction. So that would be plus or minus 1/4. The next largest number would be plus or minus 1/2. The next larger number is plus or minus 3/4. And that gives us all of the fractions that are less than 1, or at least the absolute value is less than 1. So now we need to go in order there. The next number that is larger than 1 is plus or minus 3/2, which is 1.5. Now let's go ahead and look at the other values. If I'm looking at all of these different numbers, 9/2 is approximately 4.5, so I don't want that one next. 9/4 is 2.25, so that's the next value that I want to go ahead and include in my list. So I now need plus or minus 9/4, then becomes my plus or minus 3. I've used those up. And then finally plus or minus 9/2, and again that's about 4.5, and then finally plus or minus 9. And this would be my list in ascending order of all of the possible zeros. The objective, though, for this question is being able to make this list of possible rational numbers that are zeros. With the end goal of the reason why we're doing this is to find out and be able to graph these.